Transforming functions, translations. Let us consider first the transformations of the form y equals f of x plus b. So imagine you have a general function, whatever you can imagine. So here I have not given a formula for this one. It's the green function which I call f. Okay, so the function f is the function given by the formula y equals f of x, and the f is quite general. This formula might be anything. Okay, so this is just a way in which you assign a value to a number x. Imagine you start with a number x on the x-axis given by this point here, and you assign the function value f of x to it. And if you want to plot it on the graph, what you do, you create the point with coordinates x and f of x in the plane, and this is your point A in my particular example here. So point A here on the graph has coordinates x and f of x. Now imagine a second function which is called g, and this is the function here on the graph, and the function g is going to be given by the formula f of x plus b. So this is the formula from this title. So these two functions should be somewhat related, and we should now discuss their relationship. So the function value of this new function g for the same value of x as the function value of the function f is given by the function value of x and by b when you add them together. So you take x and assign the function value f of x plus b to it, thus obtaining the point with coordinates x and f of x plus b on the graph. So therefore this point b here has the coordinates of x and f of x plus b, like that. And now let us look at it and imagine that you take this point x here on the x-axis and move it to the left or to the right. It will lead to the situation in which point A traces all the points along the f curve, and the point B will trace out the g curve. Let us look at this in motion. So here is the situation in GeoGebra. What I can do, I can change the coordinate of point A. You see what happens. These 2 points are always related, and there is this red arrow connecting them, which has always the same length. And this length of this red arrow is nothing else than the value of b, because this is what we added to the function value of this original function to obtain the function value of the new function. So this has the length of b when b is positive, and the modulus of b if b is negative, of course. Okay, so now this means that these two functions f and g are related, and the relationship is such that the function g is obtained by translating the function f, or the graph of the function f, upwards by b units. And this is written down here, so let us read it. For y equals f of x plus b, the effect of b is to translate the graph vertically through b units. If b is positive, it moves upwards, and if b is negative, then of course it would move downwards. We can see it here on the graph. When we change the value of b, for example, to negative values like this, then when we move the point x along the x-axis, it then leads to point A and B tracing out these curves. The green curve is always the same, it's the function that we started with, but the new curve is different. This time it's translated downwards. Okay, so much about this first kind of translation. This is it. It is a general consideration, so it works for any function, not only for quadratic functions, not only for reciprocal functions, for any function you can think of. Now let's move on to the second kind of transformations, and this time we are going to talk about transformations in the form y equals f of x minus a. So again, let us start with an arbitrary function f, which is this green curve here. And what we want to do, we want to obtain the new function, which is going to be represented by this blue curve here. So the original function f does the following. It takes the x and assigns the value y to it, which is given by the formula y equals f of x. Now the new function g is going to be defined by this way here. So the g function takes the value of x, first calculates x minus a, then uses the function f to calculate the function value and assigns that to y. So y is given by f of x minus a. Okay, so this is the formula for the new function. Now, if we want to start with any arbitrary value of x, what we have to do is what I have already told you. We have first we need to determine this point x minus a. So we start with x, then we construct x minus a. So this was x. Now here is x minus a. Since we subtract some value, in our case a is 3 for this graph, so we subtracted 3 from 5, we got 2. So for a given value of x, we construct this x minus a. Then what we should do, we should assign the function value of x minus a, f of x minus a. So we need to use this original green function to assign the function value to this point and thus obtain point a. So point a has coordinates, and let me draw them here. A has coordinates x minus a, and the second coordinate is f of x minus a. So it's the point on the green function, on the original function. And what we need to do now is to take this function value and declare it to be the function value of the function g. So this is nothing else than g of x. So we take this function value and say, okay, our point on our new curve is going to have the same function value, but of course different x-coordinate. The x-coordinate of point B is going to be just x, the value that we started with, and the y-coordinate is going to be f of x minus a, like this. So in this way we obtain the x-coordinate, the y-coordinate for the point on the blue curve once we know its x-coordinate. So if you know x for which you want to calculate g of x, do the following process. Start with x, then find x minus a, then assign the value on the f curve and use the same value for the new curve but for the original value of x. And this is what you end up with, this point B. Now imagine this done in motion. What I mean is the following. Imagine that you take this point x and you move it to the right or to the left. Thus, all these other points would be moved together with it, and in this way you could trace out the graph of the function f. Now I'm now going to show it to you. So let us open this in GeoGebra. So I will open this simulation. It should be this one. Yep. Edit. Okay, so here it is. Let me make it a little bit bigger. So if I take this point x and now change its value, you see that together with x, also x minus a moves, and also a and b points move. But what is important, these points a and b have always the same vertical coordinate. They just have different x coordinates. And there is this translation red vector that you can see, red translation vector, which tells you what is the translation, what is the relationship between these 2 points. So in my case, a was, let us look here, a was 3. So if I increase a, you see what happens, okay? So the original red, the original green curve remains without any effect. There is no effect on it because this is what is given, but it has effect on the blue curve. So if A is 5, the blue curve is shifted or translated to the right by 5 units. And the reason for that is that once you have the point x, then x minus a is 5 units to the left, and you take the function value of the green function at this point and use this function value for our point x. Okay, so you see how it works. Again, there is this relationship, and if a is negative, then of course we will have the translation to the other side. So look here, this time you start with the function value, with the value of x here. The x minus a value is to the right because you subtract negative numbers, so it means you have to add positive number. So this point is to the right. So the function value of the blue curve at x is the same as the function value of the green curve at the point a units to the right, okay, or modulus of a units to the right. So therefore there is this relationship. Now this can be summarized again, of course, and this is a familiar thing to you. For y equals f of x minus a, the effect of a is to translate the graph horizontally. So this translates the graph horizontally through a units. If a is positive, it moves to the right, and if a is negative, it moves to the left. This is a situation that you have encountered, for example, when you considered quadratic functions. So imagine you had y equals x squared and you had another function y equals x minus 1 squared. So you knew that there was this relationship, this function here is shifted, is obtained by shifting this original function by 1 unit to the right, okay? So when a is positive, you shift to the right. Okay, so let's move to the third and the most general case, the transformations in the form y equals f of x minus a plus b. So in this case, I'm going to need one more function. So let us start with the original function f. This is the green function here. F is defined in the following way. You use the formula f of x to calculate the value of y and assign this value to the value of x that you started with. So here is the value of x you started with, and you can thus assign the function value of this for this x. Now imagine a new function which I'm going to call g, and it's this dotted one, and the function g is defined by the formula y equals f of x minus a. Okay, so you already know that this function g should be obtained from the function f by shifting it by a units to the right. And finally, let us consider function h, which is this last function here, and h is given by the formula y equals f of x minus a plus b. So it's given or defined by this formula that we are considering here. So now we need to discuss the relationship between these three functions, and actually what is the most important fact, the relationship between the original one and the final one, the function h. So again, we start with value x here. What we do, we assign value x minus a to it, so this point here, x minus a. And then what we do, we assign the function value f of x minus a to it. Okay, so we take this point and find the function value of the green function for this point, thus obtaining the point A. Point A has the coordinates x minus a and f of x minus a. Okay, so the green f function was used to find the coordinates of this point. Now, what we need to use this same value, the function value f of x minus a, to define the function value of the function g. So we take it and use it as the function value of the function g. So therefore, we take this x and assign this value to it. So point B is going to have the coordinates of x, so there is difference with respect to point A. It has a different x coordinate, it's x, and the y coordinate is going to be the same as the y coordinate of the point A because it's used for it, so it's x minus a. like this. So the point B is the point which defines the G curve, this dotted curve. And now in the final step we need to use this value for this given x, use this value of f of x minus a and add b to it. So in the last step we take it, f of x minus a, and add b to it to obtain this point C with coordinates x and f of x minus a plus b. Okay, and this is what we need. We need to construct the point C on the graph of this new function h that we are considering here, and this would then define where it should be. And you see that the point C is related to the point A by two translations. First, A is translated by A units to the right, and then it's the resulting point B is translated by B units upwards, and thus you obtain point C. This was B because you added B to the function value of point B. Now let us see what happens if we move the original point x. If we move it to the right or to the left, everything will move except for this function f. The point A will move, the point C will move, and as C moves, it will trace out this curve of the function h, and as B moves, it will trace out the curve of the function g. So let me find this between my models and I can show it to you. So it should be this one. Okay, edit. So again, let us try to do this. So I will change the x coordinate. So this is changed, as you can see, this is being changed. Let me enlarge it a little bit. So as I'm shifting the position of this blue dot x, x minus a is shifted with it, and also points A, B, and C. And the graph of the blue function is traced as I'm doing it, and there is this relationship that you see given by these two vectors. This vector which defines the horizontal translation by A units, and this vector which defines the vertical translation by B units. And I can tweak A and B, of course. I can change A and B. So you see, if I increase A, the blue function is more to the right. If I decrease A, it moves to the left. If A is negative, it's translated to the left from the original green function, and so on. Okay, like this. There is also the effect of B. If I change B, it will lead to this motion. So if B is negative, it moves downwards, or if B is decreased, the blue curve moves downwards, and if B is increased, it moves upwards. Okay, so much for the model, and this should conclude the video, but there is this last theorem or something. For y equals f of x minus a plus b, the graph is translated horizontally A units and vertically B units. So if you ask, how can I construct the blue curve, the curve given by this formula, given the green curve, all you have to do is to shift the green curve by A units or through A units to the right and through B units upwards to get the final graph.